Okay guys, welcome to my channel. In this video that I'm gonna show you, I will be explaining about the first unit of physical chemistry, that is solid states. It carry 4 marks and you have to keep that in mind. From this unit during exam there will be one numericals that you have to tackle. Okay, let's start with the unit solid state. Solid state. I'm sure you're familiar about the name of unit solid state because we have come across from our previous class for the three states of matter, that is solid, liquid and gases, isn't it? We have studied about these three states of matter in our class 11, and in this unit we will be studying very much in detail about these solid states of matter, not only the definitions but the different types of solid. And we also have to study why some solid are hard, why some solid are soft. We'll have to study the packing efficiency in certain solids. We will also have to study the electrical and magnetic properties of some of the solid. And also you have to keep that in mind. Main thing that we have to know here is the classification of different types of solid. Okay, that is the thing that we have to study here. But before we continue with the advanced studies of the unit, I would like you to know what is a solid, or how do we define a solid state. It's not a new thing, I'm sure you know how to define it, but since the name of the unit itself is a solid state, it will be nice for us to recapitulate or to define it back, how to define a solid state. If you were asked me to define a solid state, or if you asked me to define a solid, I would define it this way. Like, solid is that form of matter which possess rigidity, hence it possesses definite shapes and definite volume. This is the thing that you have to keep in mind, the keywords, that is rigidity, all right, possess definite shapes and definite volume. That is the properties which make solid different from liquid and gases. And if you were ask me, why do solid have definite shapes and definite volume, or why do solid possess rigidity, this is the answer for the question. Because in case of solid, the so-called intermolecular force of attraction, I'm gonna note it down here, take a look. Intermolecular force of attraction of ATTR, intermolecular force of attraction. And second thing is intermolecular distance. I'm gonna write here, intermolecular distance. You know what happened in case of solid, the so-called intermolecular force of attraction is very strong. Right here, very strong. It is because of that these constituent particles in solid are bound in a fixed position. It cannot move. Hence, because of that, the solid particle, solid substance have definite shapes and definite volume. And at the same time, the so-called intermolecular distance. In case of a solid, the constituent particle, or you can say the distance between the molecule, is very small, or you can say it's almost negligible. Because of that, the constituent particle are bound in a fixed position. Again, they have definite shapes and definite volume. So these are the definition of a solid, right? As we are going to continue with a different topic ahead on this unit, first of all, I would like you to know the characteristic of a solid state. I'm gonna write it down. This is the second topic that we will study here. Characteristics of solid state. By this term, characteristic of a solid state, I mean to tell you, like, each and every solid substance must possess these properties, or must possess this characteristic, or else we won't be calling them a solid state. You follow, isn't it? So these are the characteristic of a solid states of matter. I'm gonna write them point wise, but it's not necessary that you always have to make the first point I'm writing here as the first point, or also and so on. What you need to remember here is the characteristic or the properties. Okay, so these solid, or the solid state of matter, they have a definite mass, definite shape and definite volume. These are the first characteristic. I'm gonna write here definite mass, definite shape and Definite volume. If you remember, in case of a liquid state of matter, yes, they have a definite volume, but they never possess a definite shape. They don't have a definite shape. Whereas in case of a solid state of matter, these are the characteristic of the solid state of matter. Each and every solid state of matter must possess a definite mass, must possess definite shapes, and also must possess a definite volume. Keep that in mind, right? Okay. The second characteristic of the solid states of matter, in case of solid states of matter, the so-called intermolecular distance, which I have just mentioned earlier, intermolecular distance, intermolecular distance. Here, this term intermolecular distance, I am assuming that the constituent particle of the solid that we are talking about is made up of molecule. And by this term intermolecular distance, it means the distance between the molecule in a given solid that we are talking about, okay? So the intermolecular distance are very short. And the third characteristic is that intermolecular force. Intermolecular force. In case of a solid, the so-called intermolecular force are very strong. These are the third characteristic of a solid state of matter. Okay. The next characteristic of the solid state of matter is that a very important point that you have to keep in mind. In case of a solid state of matter, the so-called constituent particle or the constituent particles are bound in a fixed position, or you can say they have a fixed position. There are many more, of course, but these are a few of the important characteristics that I will be discussing in the solid states of matter. So these are the characteristics of solid states of matter. They have definite mass, definite shapes, and definite volume. In case of solid states of matter, the intermolecular distance are very short, and the intermolecular force are very strong. These are the important characteristic of what? Of the solid states of matter. Okay, our next topic in the unit is the classification of solid. There are different way of classifying a solid, but here I'm gonna classify a solid based on the arrangement of the constituent particles. Based on the arrangement of the constituent particle. I don't know how many of you understand the term constituent particle. Let me explain it to you this way. Suppose the solid that you are talking about is made up of what? Is made up of molecule. These molecules are called the constituent particles, remember. Or suppose the solid that you are talking about is made up of what? Is made up of iron. So these ion are called the constituent particles. So constituent particle in general could be molecules, could be atoms, could be ion, could be atoms, could be ion, and so on and so forth. Could be metal as well. You got that? So these constituent particle represent the substance in which that solid is made up of. Okay, all right. The next topic here is the classification of solid. Classification of solid state or solid. Classification of solid. I'll just write here. Based on the order of arrangement of the constituent particle. Remember, this mode of classification does not base on the types of the constituent particle, based only on the order of arrangement. So based on the order of arrangement. What arrangement? Of the constituent particle. Solids are broadly classified into two different classes. Solids are broadly classified into two different classes. That is, number one, crystalline solid, and number two as amorphous solid. These are the two broad categories of classifying a solid, and this way of classification is based on what? Based on the order of arrangement of the constituent particle. That is, solid are classified as crystalline solid and Number one, number two is the amorphous solid. What do we have to do now is to find out what kind of arrangement of a constituent particle such that we will call a solid to be a crystalline solid. What kind of arrangement of the constituent particle such that we will call a solid to be an amorphous solid. Alright, let's get it started then. You know, to call a solid a crystalline solid, the constituent particle, remember, to call a solid a crystalline solid, the constituent particle must be arranged in a definite geometrical pattern, and what, in three dimension, such that there is a short range as well as long range order of the arrangement of the constituent particle. If that is the mode of arrangement of the constituent particle in a particular solid, then that solid is known as what? Is known as a crystalline solid. I'm gonna assume the example. Just take a look here. Say, suppose the solid that I'm talking about is made up of these two constituent particles. Say the constituent particle are A and B type. Right now, these constituent particle must be arranged in a definite geometrical pattern, and that also in three dimensions. Suppose this is the mode of arrangement in three dimension. Remember, I'm using the term in three dimension. If not, then we won't be calling it a crystalline solid, because in this way of classifying based completely only on the mode of arrangement of the constituent particle. So if the arrangement is in this way, we will be called, what do you see here? Regular arrangement. After this constituent particle A, then constituent particle B, and so on, repeated one after another, such that there is a short range as well as long range order of the constituent particle. If the arrangement of the constituent particle is in this way, then this particular solid can be classified as a crystalline solid. But if the solid that you are talking about, suppose, is made of the same type of the constituent particles AB, but the mode of arrangement is not orderly and is not in three dimension, then such kind of solid can be called as an amorphous solid. You have to keep that in mind. In case of a crystalline solid, the arrangement of the constituent particle are the arrangement of the constituent particle are in a definite geometrical pattern and in three dimension, such that there is a short range as well as long range order of the constituent particle. Right? But if the arrangement of the constituent particle is not regular, such that there is only a short range order of the constituent particle, that mode of that type of solid can be called as an amorphous solid. Alright, we are done with the classification based on the types of arrangement or based on the order of arrangement of the constituent particle. Here in class 12, we will not study about amorphous solid. Our syllabus deals with the crystalline solid, so we will further classify a crystalline solid. As of now, we are done with amorphous. We know only the definition and we will skip it. Alright, we will proceed with this crystalline solid. First of all, we will see what are the different types of crystalline solid. Remember, now the mode of classification of crystalline solid is based on the type of constituent particle, not on the nature, based on the type of the constituent particle. Okay, so based on the types of the constituent particle, crystalline solid are further classified based on the type of the constituent particle. Crystalline solid are further classified into different classes. Number one are known as molecular solid. The second type of crystalline solid is ionic solid. The third type of crystalline solid is metallic solid. And the fourth is covalent solid. Please keep that in mind. Molecular and ionic solid are based on the types of constituent particle, whereas metallic and covalent solid based on the types of bond or on the types of attraction between the constituent particle. What am I trying to tell you is that to call a crystalline solid to be a molecular solid, if the constituent particle are molecules, you can take the example to be, say, hydrogen solid, which in which the constituent particle are molecule. You can take the example, say, hydrochloric acid, or you can call it hydrogen chloride. All these are the example of a molecular solid. Of course, they are further classified as polar and non-polar. I will not go into the detail of that. The next type of solid are ionic solid. This one, the constituent particle are ion. You can take the example of a sodium chloride, in which the constituent particle are sodium ion and chloride ion. Another type of solid is metallic solid. In this case, the crystalline solid are classified not on the type of the constituent particle but on the nature of the bond. Here, the bond between the constituent particle is a metallic bond, alright? And covalent solid, in this case, the crystalline solid is classified not on the type of the constituent particle but on the nature of the force of attraction. In this case, the bond between the constituent particle is a covalent bond, hence it is known as what? It is known as a crystalline solid. It is known as a covalent solid. So that's all regarding with the classification of a crystalline solid. All right, there are certain terms that we need to study, that we need to know, which are used only while studying solid states chemistry. Certain terms. Those terms are, I'll note them here. The first term that we need to know here is called crystal lattice. Crystal, C-R-Y-S-T-A-L, crystal lattice. These are new term, crystal lattice. I'm gonna define it like this. Before I explain, I will define it like this. A regular arrangement of the constituent particle of the crystal. A regular arrangement of the constituent particle of the crystal in a three-dimensional space is known as crystal lattice or space lattice. A regular arrangement of a crystal in a three-dimensional space is called crystal lattice or space lattice. You can imagine that this one is my crystal, okay, in which its constituent particle are what? Are, say, iron, whatever the type of solid, but this one is the whole size crystal. These are the constituent particle, iron, right? If I will imagine how these different ions are arranged in this crystal to give me a regular geometry, I'm going to imagine that different points are arranged in space. Do you follow? Now this regular arrangement, remember this point or these dots that I have represented here, it represents a constituent particle. Now this regular arrangement of what? Of the constituent particle. This regular arrangement of what? Of the constituent particle. In where? In a three-dimensional space is known as what? Is known as crystal lattice or space lattice. This regular arrangement of the constituent particle in a three-dimensional space is known as what? Is known as crystal lattice or space lattice. You got that? All right. Next is the characteristic of a what? Of a crystal lattice. Of a crystal lattice. Characteristic of a crystal lattice. Okay, we're good to go now. What are the characteristics of a crystal lattice? These are the different characteristics of a crystal lattice. I'll write them point wise. Point 1. In a crystal lattice, each dots or each point that we draw, these are called lattice site or lattice point. And I mean, when I say lattice site, I mean the place where the constituent particle are present. Each point in the lattice is called what? Lattice point. Right, or lattice site. The next characteristic is that each point in a crystal lattice you know what, represent a constituent particle. Supposedly I assume this one as a crystalline solid in which the constituent particle are what, are hydrogen molecules. You follow? Now each of these dot or each of these point, it represent a hydrogen molecule. That is the meaning of this one. So in a crystal lattice, each point in the lattice site represent the constituent particle. Now let's move on with the next characteristic. When the points are joined by a straight line, it will give us the geometry of what? It will give us the geometry of that particular lattice. When each of these points are joined by a straight line, it will give us the geometry of a crystal. Supposedly you are trying to join only this one. Here you join. As of now you got a square, okay, but as of now you got a square, but this one is not exactly the geometry because you have not joined all the point. Do you follow this one? So what am I trying to tell you is that in this crystal lattice, when you join all the point by a straight line, this will give you the geometry of a crystal lattice. You got that? Okay. After having studied the crystal lattice, there is another term that we need to know while studying this solid state chemistry. That is a unit cell. Unit cell. A very important point that you have to keep in mind while studying this solid state chemistry, unit cell. Okay, let's take a look. I'm gonna draw this point first. Okay, now please keep that in mind that this dot that I have drawn here, it represents a constituent particles. Represent a constituent particle. Now there are how many? There are 8 constituent particle, 1 2 3 4 5 6 7 8, neglecting all these lines that I have drawn. Now the arrangement of these constituent particles are known as what? As known as a crystal lattice or space lattice. Now as you've seen, when I join all the point by a straight line, it gives me the geometry of a crystal lattice. Now what is the geometry of a crystal lattice? It gives me the cube, isn't it? Am I right? Supposedly I tried this way. I'm gonna put another now. If you're trying to see carefully, how many cubes are there? 1 2 3 4. There are 4 cubes, isn't it? In this way, am I right? The smallest part of this cube is this one point here, 1 point here, 1 1, now 1 here. Leave this.